No, we're going to grade that in class. We'll quick run over the answers, and then we'll get a score, and we'll go from there. So, no, we don't have time today. Probably tomorrow. Okay, so we haven't done example 3 or 4 yet, and then after that, today is all about good guesses. So you saw that some of these problems, you can have lots of guesses, especially if the last number is like 48 or 24 or 96 or numbers like that. You're going to have a ton of guesses. Today is all about trying to get good guesses, okay? And so we'll work through number 3, but let's again, we're going to practice the rational roots theorem, then we're going to talk about good guesses. So let's solve this using the rational roots theorem. You look at it and you say, what degree is it? Third degree, so that has 3 solutions. And as you look at it, you don't know how to factor that. So we got to use our rational roots theorem, which says identify the p's. P's are factors of the last number. So what are factors of 3? 1 and 3, and q's are factors of the front. 1 and 2. So your choices are plus or minus p over q. So I go plus or minus, and I take my p's and divide by each of the q's. So plus or minus 1, plus or minus 1/2, plus or minus 3, plus or minus 3/2. So those are my choices. Okay. Now here's the important part. Okay. 2x to the third plus 9x squared plus 10x plus 3. Everything's positive, right? What's a bad idea? What's a bad choice to try to plug something in? A negative is actually a very good choice. A bad choice would be to plug in a positive. Why? Because, yeah, you're not going to get anything to cancel out. If you plug in a positive, you're just going to add a positive on top of a positive on top of a positive on top of a positive, and you're going to get a positive result. But you need 0. So in order for it to be 0, you're going to have some positive and negatives, and the only way to achieve a negative value is to plug in a negative number in this situation. So instead of plugging in positive 1 right away, or positive 2, or 3, or 1/2, or 3/2, what would be a good number to try right away? Negative 1. So let's plug it in. 2 times negative 1 to the third is going to give you negative 2. Negative 1 squared is 1 times 9 is 9. 10 times negative 1 is negative 10. So you get negative 2 plus 9 minus 10 plus 3. You can see that gives you a negative 12 and a positive 12, which make 0. So if negative 1 is a solution, what's the factor? X plus 1. So therefore, you know that this polynomial divides evenly by x plus 1. So I'm going to use my synthetic division. Drop my 2, multiply. And you got it. X plus 1 times 2x squared plus 7x plus 3. Does 2x squared plus 7x plus 3 factor? It does. 2x plus 1 and x plus 3. If you don't want to factor that trinomial, you would have to use the AC method, or you can always resort to the quadratic formula. So what are the solutions? Negative 1, negative 1/2, and negative 3. They're all negative, right? Didn't we say that right away, that we were not going to come up with a positive solution, that none of those would work? Yes. Yeah. But this test, you'll be highly restricted in your calculator usage. Because this test, for example, I know that anybody could take this equation and just plug it in their calculator and get the sketch of the graph. So because of that, I'm not going to make a lot of very difficult arithmetic problems to work through, but you won't simply be able to use your calculator in the ways you have in the past. So far, I've allowed you guys to use your calculator almost everything, but colleges are moving to where they're doing no calculator test, period. I'm not doing that, but we will limit the use of our calculator. So if your addition, subtraction, multiplication, division is not real strong, you might make a couple mistakes on this test, but that's where we need to go. So. Okay, next problem. Okay, we do number 4. We did 5 before. We do number 4 now. What degree is number 4? Third degree. P's are factors of the last. What are they? 1, 2, and 4. Q's? Take each of the P's and divide them by each of the Q's. Plus or minus 1. Plus or minus 1/3. Plus or minus 2. Plus or minus 2/3. Plus or minus 4. Plus or minus 4/3. Is it, as you look at this, is it possible that a positive number might work? Yeah. So let's choose by plugging in 1 to start off and see what we get. If you plug in 1, you get 3 plus 10 minus 9 minus 4. So you get positive 13 and negative 13, which results in 0. So if 1 is a solution, what's the factor? X minus 1. So this polynomial is divisible by x minus 1. We go ahead and we divide it using synthetic division, which you got to pause every once in a while and say, wow, look how quickly we divided that polynomial. Synthetic division is pretty cool how quickly it works. Drop down to 3 and multiply. 1 times 3 is 3. Get 13. Multiply. Add, and I get 4. Multiply. Add, and we get 0 for a remainder. So we have 3x squared plus 13x plus 4 times x minus 1. Does 3x squared plus 13x plus 4 factor? Yes, very good. 3x and x. We have a x plus 4 and a 3x plus 1. So what are your 3 solutions? Negative 1/3, positive 1, and negative 4. Those are my 3 solutions. Some positive, some negative. So there's a really smart mathematician. His name was Descartes. He was also a theologian. He was a philosopher. He was an artist. He was a scientist. A great Renaissance man of the Renaissance era. He could do a little bit of everything. Okay? And here's what he said. He said, let's get good guesses. And he came up with this idea called the rule of signs. And the rule of signs says this. The number of positive real roots, roots, 0, solutions, those are all the same. They all mean the same thing. The number of positive real solutions is equal to the number of sign changes in P of x or less by a factor of 2. What does that mean? What does that mean? What does that mean? Got it written down? Now let's understand what it means. The number of sign changes in the polynomial. So look. Does it change from positive to negative ever? No. So in P of x, it never goes from positive 2 to negative 9. It doesn't go from positive 9 to negative 10. It never changes from positive. It's positive all the way through. So therefore, there are 0 positive solutions. Look at all your solutions. They're all what? Negative. Negative 1, negative 1/2, negative 3. He says if you don't see any sign changes, there's no real solutions. If you have one sign change, there's going to be one positive solution. Okay, and that's how he figures it out. Look at the next one. Okay, the one we just did after that. How many positives? How many sign changes are there here? You go from positive, positive, that's not a sign change, but then you go from positive to negative. That is a sign change, okay? Positive and negative is a sign change, and so you have one real or one positive solution. Look at our solutions. Negative, negative, positive. You have one. So let's try an example. I go from positive to negative. Is that a sign change? Yep. Then I go from negative to positive. Is that a sign change? And I go from positive to negative. Is that a sign change? So how many sign changes do I have? 3. So there could either be 3 or less by a factor of 2. So I subtract off 2. 3 or 1. That's the number of sign changes you get. Okay? Or that's the number of positive real solutions you have. Now, here's the deal. Question. Subtracting 2, good question. It will always be less by a factor of 2. So let's say you had a big polynomial and there were 9 sign changes. That means the number of positive real roots is either going to be 9 or 7 or 5 or 3 or 1. So 9 minus 2, 9 minus 4, 9 minus 6, 9 minus 8. So less by a factor of 2. Question. Two or 0. Exactly. Exactly. Let's say there were 2 sign changes, then it would be 2 or 0. Now here's the interesting piece right here is let's think about the negative. How many total solutions do you know there are to this polynomial? 3. Well, let's suppose that there's 3 positive, then how many negative ones are there going to be? There would be I'm sorry. If there were 3 positive, then there would be 0 negative, right? But if there was 1 positive, there would be how many negative? 2. That's what you would expect, right? Let's see what happens. The number of negative real solutions of p of x is equal to the number of sign changes in p of negative x, or less by a factor of 2. So you can't look at the original polynomial. You have to plug in negative x. So I'm going to write out p of negative x. That's going to be 3 times negative x to the third minus 4 times negative x squared plus 5 times negative x minus 2. And you'll kind of see a pattern here for what goes on. That's to test to see how many negative ones there are. The positive one was for the positive ones, and then the negative ones for the negative ones. So let's look at this. What is 3 times negative x to the third? Is it going to be positive or negative? Negative. Did that change from the beginning? Yeah. Now, negative x squared is going to give me positive times negative 4 will be negative 4x squared. Did that change? No. 5 times negative x? Negative 5x. Did that change? Yeah. Then minus 2. Did the minus 2 change? No. So you can see all the odd degrees change, all the even degrees stay the same. So let's look at this now. Are there any sign changes here? No. There's no sign changes. So let's get back to Taylor's thought. She said if there's 3 positive, there's going to be 0 negative. She's absolutely right. But if there's only 1 positive, what are the others going to be? Anybody know? Imaginary. Who said that? Imaginary. Yeah, you're either going to have 3 positive and 0 negative, or you're going to have 1 positive and then 2 imaginary. And here's the deal. Imaginary solutions always come in pairs. They always come in pairs. It's just the way they have to be. And so if they come in pairs, that's why it decreases by a factor of 2. Okay? So you're going to have 3 and 0, or 1 and 0 with 2 imaginary. And we'll get to that in chapter in the next section. Question. I'm sorry. We start out negative. It's still negative, right? So no sign change. Still negative. No sign change. Still negative. No sign change. So there are no sign changes. If I said there was, I got ahead of myself. There were for this one, but not for this one. So because there are no sign changes for the p of negative x, we have no negative real solutions. Okay? Let's do the next one. Okay? Let's test the next one. Okay? Positive. Negative. Let's look at the original function, p of x. If you plug in, if we just look at the original function, are there any sign changes right now? It always stays negative. So that means you have 0 positive solutions. Let's look at p of negative x. Negative x to the fourth. It's going to be positive x to the fourth, then make it negative x to the fourth. If we take negative x and square it, we get x squared, and then the minus sign makes it negative. We have the minus 1. So when you plug in a negative x, you get that result. That's the same as the beginning, right? Are there any sign changes here? So how many negative solutions do you have? 0. Well, how many solutions does this polynomial have? It has 4, and they're all imaginary. That means that the graph never crosses the x-axis. So we can learn a lot about a function without even graphing it. By just looking at sign changes, you can see a lot about the behavior, which is pretty interesting, I think. Very predictive. So that's how we try to get good guesses. We look at the sign change. I use that. In math, in calculus, in precalculus, I continue to use that. That's helpful. The next piece is not very helpful. You're not going to have to do a lot with it, but I want to show it to you, and you're going to make a little bit of use of it on the test. That's upper and lower bound theorem, okay? People before, you guys are asking very good questions. Keep on asking the questions you have. It helps me as a teacher when people ask questions in the middle. The least helpful thing is if we go through the whole lesson, then you raise your hand and say, I don't get it. Well, stop me in the middle of class. Otherwise I should just make videos you guys watch them at home. If you have a chance to interrupt me, interrupt me. Upper and lower bounds. Let's say that the last number, let's say you had an x to the 8th plus and all the way in, you had like 24, okay? Well, 24 would be a choice you could use, right? So would 12, 8, 6, 4, 3, 2, 1, and then you would have all the negatives, right? Negative 1, negative 2, negative 3, negative 4, negative 6, negative 8, negative 12, negative 24. Oh boy. So here's what Descartes said. Descartes said, and you guys got to remember, he doesn't have a graphic calculator where he could go to his table, right? He doesn't have that. So he's pretty good at arithmetic, but he's like, I get tired of choosing some of these numbers. And furthermore, I don't mind plugging in 1. I mean, does anybody mind plugging in 1? You kind of like that, right? Do you like the fact that the problems are written so 1 works a lot? And if 1 doesn't work, it's probably negative 1. If that's not the case, then generally 2 are negative 2. Have you run any situations where 3/5 is the one that works? No. Okay, so we try to make it pretty nice. Well, Descartes looked at it and he said, well, I don't like the fact that I have so many choices here. And I like plugging in the smaller numbers than the bigger numbers. So he says, is there a way I can figure out that 4 is the upper bound and negative 2 is the lower bound, and that the only good choices are between here? Is there a way I can figure that out? So that way I don't check those and I don't check those. you got to remember, he's doing this all by hand. He's not just doing x to the third. He's doing polynomials like x to the eighth. And he finds out that there's a decent way. Again, I don't hardly ever use this, but it gives you an idea of what you could do. Okay. Here's what it says. Let's say b is positive. If you plug b in for a synthetic division, and you divide out the polynomial, and let's suppose you get a result that looks like this. Positive number, 0, positive, 0, 0, positive, positive. Basically, the idea is you get a non-negative result, meaning you can have positive or 0. But you get a non-negative result. If that's the case, then B is an upper bound. And by upper bound, I mean you shouldn't try any numbers bigger than B. So on my little drawing I had here, that would be like the number 4. 4 would be the biggest number that you would try. You wouldn't try any after that. So if you later do the synthetic division, you can tell that that's an upper bound and you shouldn't try anything else that's above it, okay? So it says, we'll do the negative 1 in a second. It says, show that this polynomial has real zeros that are between negative 3 and positive 2. That means that negative 3 is a lower bound and 2 is an upper bound. So this is what you're going to be asked to do on your test. You're simply going to be asked to do a problem like this. Show that 2 is an upper bound and negative 3 is a lower bound. All I do is I plug it in for synthetic division. 1, 0, negative 3, 2, negative 5. I run my synthetic division. 1, 2, 2, 4, 1, 2, 4, 8, 3. What do you notice about your result? All are non-negative. Do you agree? If that's the case, then 2 is an upper bound. So for your test, you'll have to state that. You'll have to say, oh, because they're all positive, because they're all non-negative, so it could be 0, then 2 is an upper bound. Okay? Got that? Would it be good of me to try 5 as a solution? No, 10, 35, 2. 2 would be a reasonable check because well, no, 2 is an upper bound, excuse me. So, and we know it didn't work because you got 3. So 1 would be another solution I could try, okay? All right, well, let's say that A is negative, okay? Let's say you got another number you're trying and it's negative, okay? And you want to check to see if it's a lower bound. Well, when you run it through, if you get something like this, positive, negative, positive, 0, negative, positive, 0, positive, meaning you have alternating signs. And 0 counts as an alternating sign, okay? 0 counts as an alternating sign in this case. Then A is a lower bound. So this is our last example we're going to do today. Question. You're here? That why question is pretty tough right now. I'd have to show you in the proof to really give you a good answer. Otherwise, what we can do, Taylor, is I'm writing the shorthand version of what your book says. If we look at the exact language that your book uses for this definition, it might make more sense then. Zero doesn't count as a sign change. The idea is that it has to be non-negative. In this answer over here, as they tell you what it is, they use the terms non-positive and non-negative, and that's just a fancy way of saying alternating signs where zero counts as a sign change. And I just think that that's probably easier to understand. But if we look at the book, we might see a better idea why. Otherwise, we would have to look at the proof to really understand why. So let's show that -3 is, in fact, a lower bound. The way I do it is I run it through synthetic division, and I look at my result. 1, -3, -3, 9, 6, -18, -16, 48, 43. What do you notice about the result? You have alternate signs all the way through. Therefore, -3 is a lower bound. -3 is a lower bound. That's all I'm going to be asking you to do on the test, is to verify the upper and lower bounds in that way. So, I wanted to then put it all together and do these two examples, but that's just not going to happen. So we're going to have to do that tomorrow. Question? What I want you to do tonight, you're going to have time in class to work tomorrow, and after tomorrow, we'll be done with 3-3. 3-4 is a one-day shot. So Wednesday, we'll be done with 3-4, and then 3-5 does not take too long either. You're going to be set for a test already on Tuesday of next week. That's good news, because you want to get your tests in before Christmas break. Because we come back from Christmas break, you got Thursday and Friday, and then that next week we prepare for your final exam and take it on that Thursday and Friday. So we don't want to come back from Christmas break and have to make up a bunch of stuff about logarithms, because we'll forget half of it. Yeah. -3 is a lower bound. Sorry. Is. I-S. That's all right. My is always get kind of... When I write it together faster. Your stuff's right there. You're welcome. We wrote in your books. No problem. So what I want you to do is these 8 problems, 51 through 54 is where you're going to look at the sign change and identify the number of positive or negative roots. And then 57 through 60, you're going to look at the upper and the lower bounds. So there's not a whole lot to your assignment. If some people first hour said, I've got to start moving because I haven't done a single assignment yet, yes, then you're behind, okay? Because we're a week away and we're going to test, okay? We don't have a lot of time to putz around, so if you got to get on top of your homework, get on top of it. You had a nice break from Thanksgiving. We got 3 hard weeks of work, and then you got your final exam. So, all right, there you go.